If you're an engineer trying to get into AI right now, you know how wild and crowded it is out there. So how do you stand out? Well, it's about going deeper than just calling the latest API. We're going to dive into the 5 foundational papers that give you that critical edge, the ones that really define the industry.
I mean, it's no secret, right? The demand for AI skills is just through the roof. We are smack in the middle of this huge technological shift, and it's creating some absolutely incredible opportunities for engineers who can actually build, tune, and deploy these systems.
But this brings us to a really important question. AI tools, they can make us way more productive, for sure. But does that automatically mean the code is better? Without a real understanding of what's happening under the hood, these tools can just help us make mistakes faster.
You know, I saw this comment on Reddit that it perfectly captures the problem. There's this huge temptation to just accept whatever the AI spits out. But that's why engineering rigor, that fundamental knowledge, is more important now than it has ever been. And that's exactly what we're here to build today.
Okay, so our journey starts back in 2017. A single paper came out that completely changed the game by solving this one fundamental problem that was holding everything back. This is what unlocked the power we see everywhere today.
So before 2017, models like recurrent neural networks, or RNNs, had to process text word by word by word in a strict sequence. You can imagine how slow that was, right? You couldn't really parallelize the work, and even worse, if you had a long sentence, by the time the model got to the end, it had often forgotten what was said at the beginning.
And then came the paper, Attention is All You Need, with this absolutely revolutionary idea, self-attention. Instead of that slow, sequential process, the model could look at all the words in a sentence at the exact same time. For any single word, it could calculate an attention score to figure out which other words in that sentence were most important for understanding its meaning.
And this right here is the heart of the transformer architecture. It's built entirely on this attention mechanism. The diagram on the left kind of shows the basic math, using things called queries, keys, and values to weigh word importance. But the real magic is on the right, running multiple attention heads in parallel. Think of it like each head is looking for a different kind of relationship in the sentence. One might track grammar, another might track who did what to whom. And because you can run all these heads at once on GPUs, it completely replaced that old, slow sequential processing. This is the engine inside every modern LLM. So we've got this incredibly powerful engine. But how do you get it to do specific, useful things? The next giant leap forward answered a huge question. How can we guide a model without having to rebuild it from scratch for every single task? See, the old way of doing things was to take a big model and then fine-tune it on a massive custom data set. If you wanted it to summarize legal documents, you needed thousands of examples. If you wanted it to write marketing emails, guess what? You needed another giant data set. It was a huge, expensive bottleneck. Then the GPT-3 paper dropped, and it revealed something stunning. Just by making the transformer model big enough, a brand new ability emerged called in-context learning. So instead of retraining the model's weights, which is super expensive, you could just show it a few examples right there in the prompt. You could see it here. Give it 0 examples, 1 example, or a few examples, and the model just gets the pattern and does what you want. This discovery made these huge models so much more practical and accessible to everyone. Okay, so the models are powerful and we know how to prompt them to get things done. But 2 massive practical problems came up pretty fast. First, the insane cost of tuning these models when you really needed to. And second, the challenge of making sure they were helpful, truthful, and, safe. Let's hit the efficiency problem first. On the left, you have full fine-tuning. You're updating billions of parameters. It's wildly expensive. Then, this technique called LoRA, or low-rank adaptation, came along. The idea is absolutely brilliant. Instead of changing the entire model, you freeze its original weights and just inject these tiny, trainable adapter matrices into its layers. And the result? It's a game changer. You end up training 10,000 times fewer parameters. Suddenly, custom fine-tuning became practical for just about anyone.
But look, efficiency is only half the battle. A raw language model, even a fine-tuned one, is really just a super-powered next-word predictor. It might generate stuff that sounds perfectly plausible, but is just factually wrong, or toxic, or totally unhelpful. This is what we call the alignment problem.
The InstructGPT paper gave us the solution for this: reinforcement learning from human feedback, or RLHF. It's basically a 3-step recipe. First, you do some basic fine-tuning with high-quality examples. Then, and this is the key part, you have real humans rank different outputs from the model. A totally separate reward model is trained on that ranking data to learn what humans prefer. And finally, You use that reward model as a guide to steer the original LLM, using reinforcement learning to make it more helpful, honest, and harmless.
So at this point, our models are powerful and we can steer them, but they're still fundamentally disconnected from the real live world. The next huge challenge was, how do we give them access to up-to-date knowledge and the ability to actually do things?
A model's knowledge is basically frozen in time, right? It's stuck with whatever data it was trained on. It has no idea about today's news, it can't read your company's latest internal documents, and it definitely can't check your calendar. It's just trapped inside its own parameters. So the most common fix for this knowledge problem is a pattern called Retrieval-Augmented Generation, or RAG. It's pretty clever. Before the LLM tries to answer your question, you first go and retrieve relevant info from an outside source, like a database of your company's documents. Then you just stuff that fresh information right into the prompt. That gives the model the context it needs to generate an answer that's factually grounded and up to date. This is a core pattern in production AI systems today.
Okay, but what if you want the model to do more than just answer questions? What if you want it to book a flight for you, or send an email, or actually query a database itself? Well, that's where we move from just retrieving information to taking action.
And this brings us right to the cutting edge, LLM-based agents. An agent is a system that uses a large language model as its reasoning brain to plan tasks and use tools to get stuff done. And just look at this timeline. The field absolutely exploded in 2023. In just a few months, we went from early ideas like Toolformer, which taught models to use APIs, to way more complex systems like Tree of Thoughts for advanced problem solving. This ability to act, not just respond, is where the whole industry is heading right now.
So we've covered the core architecture, how to prompt them, how to tune them, and how to connect them to the real world. So what does all this mean for you, the engineer?
This quote just says it all, doesn't it? An engineer's value isn't just about writing code from a blank screen anymore. It's about being the expert who can guide the tool, critique its output, spot those subtle bugs, and integrate its strengths into a really high-quality system. And you simply can't do that if you don't understand the fundamentals we've just walked through.
When it comes down to it, these papers aren't just some academic exercises. They are the actual blueprints for the tools that are defining our industry. Understanding them is the difference between just using AI and truly engineering with it. The tools are here, so the only question left is, how will you learn to master them?